Hello everyone, welcome to another video. Today I want to introduce you to managed namespaces in AKS. The idea behind managed namespaces is that it allows you to have a multi-tenant AKS cluster and easily take care of the various namespaces. This means you can give permissions for the namespaces, for example for different teams, and you can also easily set quota, therefore ensuring that one team doesn't use all the resources of your cluster and therefore starve the other teams. As a bit of a warning, this feature is in preview, so it might change over time. It's not 100% stable, but I think it can be a very handy feature, especially as said for multi-tenant clusters, and this is what I want to show you today. So the plan for today is, first I'm going to go through all the steps necessary. This means we're going to set up a new AKS cluster, then we create a managed namespace, then we're giving a demo user permissions to access this namespace, and we're going to test everything. After the demo, I'm also going to show you a couple more additional parameters that will allow you to manage, for example, the ingress and egress of your namespace. As always, if you're interested in the demo instructions or the slides, you can scan the QR code, or you'll find the link in the description down below. Also, as always, I will have the chapters, so if you're interested in a specific topic, you can just skip ahead. And with this said, let's switch over to the terminal and let's get started with the demo. All right, here in the terminal, before we get started, let's define a couple of variables. So first, we're going to define the variables for our AKS cluster. This means the name, the location, and the name of the resource group. Then we define a couple of variables for our namespace. So this is going to be the name of the namespace and also a couple labels and annotations just to show you how we can add them while we create our namespace. Lastly, we're going to read the subscription ID, the email of the user that's logged in right now. So this is going to be my user, the admin. And also I am defining the email address of a demo user. We're going to use this demo user to access the managed namespace. With the variables in place, now we have to install an extension for the Azure CLI. It's called AKS Preview. So you just use AC extension add. If you don't have it installed, it will install it. And as we can see, it tells me I have already installed it. But you can also do an AC extension update with the name, and then you will update to the newest version, which I also already should have installed. Next up, we have to enable the feature flag for the managed namespaces. And we do this with an AC feature register. Then the namespace is Microsoft Container Service, and the name of the feature flag is Managed Namespace Preview. This might take a couple of minutes the first time. And here in the state, it will be saying registering. And as you can see here, for me, it says registered because I've already registered in the past. That's something you only have to do once per subscription. In case you want to check the status of this feature flag, you can just do an AC feature show, provide the same name, and then we'll see also here that the state is registered. Once you have enabled this feature flag, we also have to update our provider. So you just do an AC provider register and use the same namespace as before, the Microsoft Container Service, but this time without a feature flag. That's everything we need to set up. Now we're good to go to create our cluster. First, I'm going to create a new resource group with the name I've defined before and the location. And now I'm going to create our AKS cluster. Again, here I provide the name and the resource group I've defined before. And what's important is that we add these two parameters. So the enable AID is for the Entra ID Authentication, and the enable Azure RBAC is for the Azure RBAC permission management, because this is needed to have the authentication and authorization for our managed namespace. Creating the AKS cluster will take around 5 to 10 minutes. And once the cluster is created, we will continue with creating our matched namespace. Our AKS cluster is created. Now we can create our matched namespace. So I'm going to paste the command here and then we're gonna take a look at it. So first we provide a name for our namespace for our AKS cluster for the resource group. Then we configure the quota. This means we configure the CPU and memory request and also CPU and memory limit. So this is the maximum amount this namespace or pods inside this namespace are allowed to use. So this is going to be important for the demo later. Then we provide the labels and the annotations. And on the bottom here, we have 4 parameters that we're going to take a look more at the end. But the values are configured here are the default values. So if you leave all these 4 parameters out, you will get the same configuration what I've configured here. So the deployment of the matched namespace is already running, and I had various results in the past. Sometimes it takes 2 seconds to create the namespace, sometimes it takes a couple minutes, and sometimes it says it failed, but it created the namespace. And here you can clearly see it's still in preview. So for now I'm going to stop the video. Let's gonna wait a couple minutes until it's created and then we'll continue. It took around 2 minutes, but the namespace has been created. Now we can configure a couple of permissions and then we can test our namespace. So first I'm going to assign myself the Azure Kubernetes Service RBAC cluster admin permission. So this is basically the administrator of the cluster. And as you can see up here, I'm assigning it to my own user. And I've also used all the variables everywhere. So if you just paste this command, it will work without any changes needed. That's already executed. Now we can download our AKS credentials and then log in into the cluster. So just use an AKS get credentials. And since we're using Entra ID Authentication, we also have to do a kube login. This will log us in using the credentials and our Entra account. And if I wasn't logged in, it would have opened the browser so I can sign in. Since I'm already signed in, it just skipped this step. Now I'm connected to the cluster and I can just execute Kubernetes commands like kubectl get namespace. And here I will see all the namespaces inside the cluster. And we can also see our matched namespace here. So that's just a normal Kubernetes namespace. But we configured some quota. And if I try to run now just a normal pod, we'll get an error message. So if I just run kubectl run nginx, I provide the image nginx and I use this matched namespace as my namespace. If we execute this, I'll get an error message and you can see here it says forbidden and it failed because there are no quota. Must specify limits for CPU and it also should say limits here for memory. This means we are also enforcing that every pod running inside this namespace has to have these limits configured. But for us now, while we tested, we didn't get a forbidden message in general to run pods. So we should be able to run pods in this matched namespace. But now I want to set up the demo user and I want to configure this demo user that they are only allowed to run inside this matched namespace. So for example, this could be my development team A. It has this namespace and in the future I could create a new namespace for the development B. To do this, first let's query the ID of this matched namespace. To do this, we use the AKS Namespace show command. We provide the name of the namespace of the AKS cluster and the resource group, and then we query for the ID. And we also store this inside this namespace ID variable. So as we can see here. Now we can use this to assign permission to our demo user. So again, we use AC role assignment create. This time we use the demo user. And here we can have some specific namespace permissions. For example, the Azure Kubernetes Service namespace user. And this user gives the permission to download the credentials for this namespace. And for the scope, I use the namespace ID. So now the user, the demo user, is allowed to download the credentials, but the demo user doesn't have any permissions to do anything inside this namespace. So we have to assign a second permission. And in this case, I'm using the Azure Kubernetes Service RBAC writer permission. This means this user can just create deployments, pods, and should be able to do the normal work. Should only take a couple seconds, and then the permissions are assigned. This is everything we have to set up. Now I can log in with the demo user and test the access. So first, let's log out with AC logout. Then I always like to do an AC account clear. This is because the Azure CLI sometimes caches account information, and if you switch between accounts, it's just cleaner to clear everything up. Now we can do an AC login. This will open the browser. As you can see here, I have my two accounts. I just picked the demo user and I'm already logged in. So let's close this, select the one subscription I have, and everything should be fine now. The next step is to download the credentials. And here we see something unique to managed namespaces. So if I paste the command is this time AKS Namespace get credentials. Then we provide the name of the namespace, the resource group name, the name of the AKS cluster. So if you remember before, or in all the other cases we have with AKS, we use AKS get credentials. This means we download the credentials for the entire cluster, but in this case, we only download it for the namespace. This is because our user doesn't need to have any permissions on the AKS cluster, only on the namespace itself. So if I would try to execute this AKS get credentials command, I'll get an error message because this user doesn't have permissions and also doesn't need permissions. So this makes the whole user management cleaner, and I can give out only the permissions needed. But we already downloaded the config. Now we can test our permissions inside this namespace. So first, again, I do a kube login to make sure that I'm logged in with my Entra account. Now we could do, for example, a kubectl get namespace. If I could type kubectl get namespace. And as you can see, I'm not allowed to list the namespaces inside my AKS cluster. I'm only allowed to execute operations in my own namespace. So now let's going to deploy an application. And while the application is being deployed, we're going to take a look at the file itself. But for now, let's just execute a kubectl apply, provide the file name. As always, you will have the file on the GitHub. So this creates a deployment and a service. And if you open this file, then we can see here it's as basic as it can be. I've provided the name of the namespace. I want to create 3 replicas. I'm using Nginx because that's a simple image. What's important is I have here my request limits and requests and limits defined. If I don't define them, I will get an error message and I'm not allowed to deploy my pods or application. On the bottom, we also have a service. So just to show you, it will work the same way you use normal namespaces. We create a service. Azure will give us a public IP address, and then we can, if we want to, access our Nginx. Now let's switch back to the terminal and let's see if our pods have been deployed. Back in the terminal, let's do a kubectl get all, and we'll see what we have running in our namespace. As you can see here, it tells me I'm not allowed to execute any commands in the namespace default. So that's something that would be nice if AKS could take care of, but I'm not sure if it would be possible since we're using the kubectl. But I'm logged into one namespace, so it would be nice if it could execute my commands only on this namespace. For now, it's not possible, and therefore we have to provide the namespace at the end. So that's our managed namespace. Now we should see everything that's running inside this namespace. All right, so as you can see, we have our service here. We have a public IP address, but we only have 2 of 3 pods running. So now we can take a look why this happened. So first up, we're going to take a look at the deployment. So just kubectl get deployment. And here we'll also see 2 out of 3. The next step could be we're going to describe this deployment. So we do a kubectl describe deployment and provide the name. But this doesn't give much information. So it just says 2 out of 3 replicas created and it failed to create. But it doesn't give us a reason why it failed. And the reason why this happened is because the deployment creates a replica set and then a replica set creates the pods. This means we have to take a look at the replica set, why it didn't work. So now we do a kubectl get replica set. This will give us the name. With this we can do a kubectl describe replica set. Then we copy the name. And we also again add our namespace at the end. Now you can see here we have a couple error messages, but it says here failed to create. So that's what we're looking for. Something is forbidden, and here you can see exceeded quota. And all the way down here, it tells us the limit is 1 GB for the memory. So this is already an indication that we are exceeding our quota. Now we can take a look at our quota. For example, we can do a kubectl get quota, and we provide again the namespace. This will give us a nice overview. So we can see here for the limit, we are using 1 of our 2 CPUs, but for the memory, we are already using 1 GB and we only have a maximum of 1 GB. If we take a look back at our deployment configuration, then we can see here with the memory, we configure a limit of 512 MB. Then this worked. Then we created a second pod. Now we have a total limit of 1 GB, and this is the maximum we had. Then we tried to create the third pod, and since we had the quota, it didn't work. So this is exactly what we configured and what we wanted to do. So in this case, we prevented the demo user of using too many resources inside the cluster. This showed how useful managed namespaces can be, and I think that's a feature to look out in the future. Now let's switch over to the Azure portal and let's take a look how the managed namespace is represented there. Here in the Azure portal, I have my resource group, the one we created before. If we open this resource group, we'll see we have our AKS cluster, but we also have this new resource, Manage Kubernetes Namespace. If you open this one, then it looks like every other Azure service. So we have an overview page where we get some information. For example, we have here our CPU and memory requests and limits. We have the access control, so we can see who has access, and we also have our workloads down here. So we can see we have 2 out of 3 pods running. Something doesn't work as expected, and if we wanted to, we could click on it, then get to the replica set, and in the end get to the error message. The same thing we did in the kubectl command line. Compared to Kubernetes, as you can see, it's very limited, but again, it's a preview feature, and I'm not sure if you need too much more information because you don't manage anything. You only have your applications inside your namespace. So I think this might be a great approach for teams to get started. This is everything I wanted to show you in the demo. Now let's switch back to the slides and I will show you the 4 additional parameters I told in the beginning, what they do and how we can configure them. All right, back in our presentation, the first additional parameter we have is ingress policy. There we have the options to use allow all, allow same namespace, or deny all, where allow same namespace is the default value. So as the name suggests, it configures the ingress, and by default, you're only allowed to communicate within the same namespace. This means if an application in another namespace tries to access your application, it will not work. If you don't want to allow all communication, this means from all namespaces, then you would have to write your own networking policy. But I think to get started, this should be good enough. The next one, the egress policy, is almost the same. So again, we have here the allow all, the allow same namespace, and the deny all values. But here the allow all is the default one. This means your application is allowed to access everything that's out there and communicate with anything. Next up, we have the adoption policy. Here we have the values never, if, identical, and always, whereas never is the default value. And this decides what happens if a namespace with this name already exists. This means a Kubernetes namespace and not a managed namespace. With never, if a namespace already exists and you try to create a managed namespace, then the deployment will fail. If identical means that it will convert the Kubernetes namespace to a managed namespace if the existing one is identical with the one you want to deploy. Here Microsoft doesn't provide an explanation what identical means. I could imagine that it has the same quota configuration, but it doesn't specify yet. So I guess this will be updated in the future so it's clear. And the last option is always. This means that the managed namespace will just try to take over the Kubernetes namespace. The last parameter we have is the deletion policy. And here you can decide what happens when you delete your managed namespace. The default option is keep, or we also have the option delete. With keep, this means if you delete the managed namespace, then it just deletes the managed part. But the Kubernetes namespace and the applications inside this namespace remain. If you use delete, then it will delete the entire Kubernetes namespace and therefore everything inside the namespace. That's everything I wanted to show you today. As we have seen, we can easily create a managed namespace inside our AKS cluster. Then we can give permissions to users or to groups. And then these users or groups can only access anything inside this namespace. But they don't need to have access to the entire cluster. Additionally, we've seen we also have to provide resource limits and request limits. Therefore, making sure that we only use as many resources as we're allowed to. And this is a great feature or approach to manage a multi-tenant cluster. This means we can have multiple managed namespaces and we spread them out through our teams. And with managed namespaces, we can ensure that we don't run out of resources because one team is using way too many. You can densely pack the applications on your worker nodes. Therefore, use as many resources as you have. Additionally, if you have one team that manages the cluster, then all the other teams can just use it, basically a cluster as a service. For now, it's still quite early in the preview. It's not too many features. For example, we have the quota and the permissions, but nothing else. So it would be great to see even more features, but I think that's a very interesting new feature in AKS. And we'll see where it leads in the future. I will look into it again in the future. Is there something interesting? I will create a new video. But for now, I wish you a great week and I hope to see you next week again for a new video.